So before entering to the K-map concept, first we have to discuss about the min terms and max terms. That is, what is min terms and what is max terms. So we have to discuss. So before this min terms and max terms, first you have to know about what is SOP and what is POS. So SOP means sum of product and POS means a product of sum. That is, if a equation is like this, that is, one sec. If a equation like this, that is y is equal to AB plus BC, means it is called sum of products. That is sum of these products. That is the product term is AB and BC. Okay, so those products terms will be summed up. So that is called as sum of product. And if a equation like this means that is A plus B into B plus C. Okay, if the equation is like this means it is called as POS, right? So first of all, you have to know these things because it is very important for K-map simplification. Okay, so here I'm just mentioning the table for the min terms and max terms. So here just taking the 3-bit concept, that is the input variable is A, B and C. Okay, so since it is a 3-bit concept, I'm just using 4 to 1 concept to write down the variable. That is for 0 ka 0 0 0 and for 1 ka 0 0 1. Otherwise you just put like vertical, that is 4 zeros 4 1 and 00 11 00 11 and 01 01 01, like this you have to mention. And what is min terms means, so if you are going to write min terms now, so you have to write the terms in product term. Okay, so in the same case, if you write the max terms means you have to write the terms in sum terms. Okay, that is the major difference between min terms and max term. Okay, so first if you want to write the min terms means since it's a 3-bit variable, so here I'm just mentioning the 3-bit terms. So if it is a 0 means you have to put bar and 1 means without bar. Okay, so 0 means bar will be there and 1 means bar is not there. That is the concept for min term. And if it is max term means 0 means bar is not there and 1 means bar will be there. Okay, that is the major concept of min terms and max term. For example, since it is a 0 0 0, okay, so if it is a min terms now, so since it is a 0, so that means A bar and B bar and C bar. That is the concept. Okay, so A bar, B bar and C bar. Okay, since it is a min terms means, okay, so in the same case you can see this is what the min terms are for the 0 0 0. Okay, so A bar, B bar and C bar, that is equal to M0. Okay, so since it is the same concept for max terms means, that is 0 0 0 means, okay, so max terms la 0 means without bar and 1 means with the bar. Okay, and also you have to write the equation in sum terms. Okay, so that means A plus B plus C. Okay, well, likewise you have to write it. Okay, so for example, for 1 1 1 we have to write for min terms and max term. Since it is a 1, okay, well, so in terms of min term la, so 1 means without bar and you have to write the equation in multiplication term. Okay, well, so that means A into B into C. Okay, well, so in the same case, if you write it in the max terms means, so since it is a max term, 1 means bar will be there and 0 means bar is not there. As well as you have to write the terms in sum. Okay, so that means A bar plus B bar plus C bar. Okay, so this is what min terms and max terms. Okay, so for example, they just given one simple term, that is f of A comma B comma C is equal to A bar B bar C bar plus A bar B bar C plus A bar B C plus AB C bar. Okay, so if they ask the sum like this means, so it is very simple. Since it is a min terms, okay, so bar means 0 will be there and without bar now 1 will be there. Okay, so simply put, so since it is a bar, so this is 0 and this is 0, this is 0. Okay, so and the 0 0 and 1 will be there, and here 0 1 1 will be there, and here 1 1 0 will be there. Okay, so the next step is you have to follow 4 to 1 concept. So this is 4 and this is 2 and this is 1. Okay, so you can see, so 4 2 1, there is no ones will be there, all will be 0. Okay, that means it is M naught. And then here it is 1 will be there Okay, that means it is represented as 1, so m1. Okay, and here 2 and 1 la, that is this is 4 and this is 2 and 1, so 4 la bar will be there, so that means it is 0, and 2 and 1 la, so there is no bar, so since it is 1 1, okay, so 2 plus 1 is equal to 3, so this is m3. So likewise here, so 4 plus 2 la without bar, and 1 la bar will be there, so 4 plus 2 is equal to 6. Likewise you have to mention. Okay, so since it is a sum term, so finally we just mention summation small m 0 comma 1 comma 3 comma 6. Likewise you have to mention. See, so you can see this is what the final answer. This is what the final answer. Okay, so next likewise if the max term will be asked now, so I hope we already discussed. Okay, max terms means without bar na it is 0, with bar na it is 1. Okay, so that means this is 0 0 and 1, and this is without bar, so 0 1 1, and this is 0, sorry, 1 1 0 will be there. Okay, well likewise this is 1 and this is representing 3 and this is representing 6, so it is called as capital M1, capital M3 and capital M6. So finally it is represented as pi capital M 1 comma 3 comma 6. So likewise you have to mention the min terms and max terms. Okay, next we just go for simplification of Boolean function using Karnaugh map. So you can see this is the structure of K map. So K map there are in basics there are three types will be there. One is two variable K map, another one is three variable K map, and the third one is four variable K map. So two variable K map this is the skeleton. That is we have only two input, that is A and B. Okay, so this is 0 and this is 1, and this side 0 and this side 1. Okay, so that means so 0 0 means A bar B bar, and what about this bar? This box will be there, that is 0 ki A bar and 1 ki B. Okay, so likewise you have to mention. So since it is a three variable K map now, so left side you have to take the input called A, and for the right side you have to, there is the right topmost side you have to take the input called B and C. So since it is a single input, 0 and 1 will be there, and since it is a dual input, we have 0 0 0 1. Actually 1 0 and 1 1 will be there, but in the K map at the same time we can't able to change two bits at the same time. So that is why 0 0, after that 0 1, then 1 1, and then 1 1 0 will be there. Okay, that is the reason. Okay, so that is what the reason. So you can see 0 0 0 1 1 1, and then 1 0 will be there. So likewise you have to mention. Okay, so and next this is the four variable K map, that is uh, uh, left side two inputs and the right topmost side two inputs, that is AB, and this side CB CD. So 0 0 0 1 1 1 1 0. So likewise 0 0 0 1 1 1 1 0. Okay, so if you want to find what is the answer for this box now, it is very simple. So what is the input of this? You can see, so this value and this value will be combined for this. Okay, so that means what about the input of this 1 1? That means A into B. And what about this value? This also 1 1, that is C into D. So the answer for this block is AB into CD. Likewise, you have to mention. For example, you have to write, if you want to write this means, it is very simple. What about the input of this block? This one and then this one, right? Okay, so what is the input of this one? That is AB 1 0. Okay, 1 0 means A into B bar. And what about this? C into D bar. So what about the answer for this? A into B bar and C into D bar. That is what the answer. Okay, so this is how you have to draw the skeleton of the K map. And one more important thing, inside every square you have to write one numbers. Okay, you can see, so this is 0 and this is 1, and 2 you have to write here only, because one shift will be there. Since I already told you 0 0 0 1, next stage is 1 1, after that only 1 0. Okay, so that is why here I'm just mentioning 0, here I'm just mentioning 1, and this is 2 and this is 3, and here 4 and 5, here 6 and here 7, and then 8 you have to write here 8 9 10 11, and then 12 here, 13 here, 14 here, and 15 here. Okay, so this is how you have to draw the skeleton of the K map. Okay, so the first sum, they ask us to plot the Boolean function. It is very simple sum. Okay, so plot the Boolean function y is equal to AB into C bar plus AB into C plus A bar B bar into C. It is very simple. Okay, since it is a 3 variable K map, you just to draw the skeleton of 3 variable. Okay, this side A and this side BC. Okay, 0 1 and this side 0 0 0 1 1 1 and 1 0 will be there. Okay, so first you have to represent the A B C bar. That means what is the value? A is equal to 1, B is equal to 1 and C bar is equal to 0. So we need to plot 1 1 0. Okay, so where it is, so this side 1 will be there and 1 0 where it will be there, so this side. So the meeting point of this and this will be the A B into C bar. Likewise, you have to draw. Okay, so what about the second term? A into B into C. So that means 1, 1, 1. So where it is, so actually the A1 is here. Okay, so and the BC11 is here. So the meeting point is here. So you have to draw here. Okay, likewise you have to draw it. Right? So this is what the plot sum. Okay, well, next we just go for minimize, that is a minimize kind of sums. Okay, so you can see the first sum, it is a 3 variable K map. So they ask us to minimize the Boolean expression, that is y is equal to A into B bar into C plus A bar B bar C plus A bar B C plus A B bar C bar plus A bar B bar C bar. Okay, so first you have to draw the K map. Okay, first you have to plot the K map. Okay, so whatever the terms they just mentioned, so for the term, okay, you have to put 1 and for the remaining term, okay, you have to put 0. Okay, so the next step is you have to map the ones, that is map the number of ones. So the mapping priority is, so the first priority of mapping is 16, next 8, next 4, next 2 and next 1. So this is what the priority. Okay, so and one more important thing, so as much as possible, you have to map the ones. That is very, very important. For example, first you have to go for the maximum number of ones. Okay, then you have to reduce the size of the mapping. That is very, very important. Okay, so in that condition, what will be the first mapping? You have to see, so this 4 1 is the first mapping. Okay, so this 4 1 is the first mapping. Okay, and what about the remaining? Actually, only 1 will be there. Here, there is a condition. Instead of mapping this one alone, if you map with this means we have to reduce further. That is why the map is like this. Okay, so 4 1 is the first mapping and the second double 1 is the second mapping. So for that you have to write the simplification. So that is also very very easy. Okay, for the simplification you just to draw, you just to write, so A B C. Okay, so now I am taking this simplification. Now I am taking this simplification means you have to write each one's input here. Okay, so that is what the simplification. You can see for this one, what is the input? 0 0 0. So that means right here 0 0 0. And what about this one input? 0 0 1, right? So 0 0 1. And what about this input? 1 0 0 1 0 0. And what about this input? So 1 0 1. Okay, now what you have to do now, you have to check vertically. Okay, well, check vertically. So in that case, if the ones and zeros are changed now, you have to eliminate the term. Okay, for example, you can see check vertically, that is here zeros and ones are changed, so that means the A term will not be there in the answer, right? So likewise C also changing, so that term also not there in the output. Okay, so B term alone not changed. Okay, so in that condition B term will be there in the output. Okay, so also in that situation, if the term contains 0 na, you have to put bar, that is B zeros, so bar. Okay, likewise you have to make the simplification. So this is the 4 1 mapping the simplification, and for double 1 here I'm just mentioning the simplification. You can see 0 0 1 and 0 1 1. So here only one term will be eliminated, that is B will be eliminated. So since A having 0, so that is why I'm just to put A bar, and C having 1, so that is why I'm just to put C as a without bar. So both the combination will be the output, that is A bar C plus B bar is the output term. So the input term having 5 terms and the output term having only 2 terms, which can contain only 2 terms in the first variable and a single term in the second variable. So this is how we have to make the minimization, right? Okay. So the next sum we'll see one important sum. So now we are solving the SOP, right? So in the same case, they just ask the POSM also. So the POSM is asking like this, that is y is equal to pi capital M 0, 1, 4, 5, 6, 8, 9, 12, 13, 14. Okay. So if it is POS now, so the given terms you have to put zeros in the K map and you have to map the zeros. Since it is a since if it is a SOP now, the given terms you have to put 1 and you have to map the 1. Okay, here we just put we just ask the POS. So put given terms I'm just putting zeros. Okay, and then the maximum 0 is, so first this will be the maximum mapping. Okay, this will be the maximum mapping, and the second mapping is very crucial. Okay, but you can see instead of mapping this to 0 alone, there is a concept called folded mapping. Okay, so that is what is folded mapping now? This 2 0 combined with this 2 0. Okay, so this is how you have to mapping in terms of folded mapping is available, right? So next concept is same da. Okay, for the all the 0, okay, you have to write the inputs, and for all the second mapping you have to write the inputs, and in that the changing term will be eliminated and the remaining term you have to write the answer. Okay, but in the SOP la, if it is 0 now, we have to put a bar. Okay, but in this case it is a POS, so 0 now without bar, 1 now with bar. Okay, so that is why you can see C terms having complete zeros, so that is why I'm just to put C alone, it is not bar. Okay, likewise here also, and don't forget to write the answer in the POS form. Since it is a POS, that is C plus, okay, C plus, sorry, it is not C plus. Okay, the answer is y is equal to C into B bar plus D. Likewise, you have to mention. Okay, this is how you have to solve the K map. Okay, so don't forget, if it is min terms na 0 na A bar, 1 na A. And if it is a max term na 0 na A, 1 na A bar. That is if it is summation or small m na min terms. And if it is pi and capital M na, it is max terms. Okay, this is how we have to solve the K map. So, and one more case is there, that is the don't care condition. You can see, so the next sum, simplify the Boolean function f of a, comma b, comma c, comma d is equal to summation small m 1, 3, 7, 11, 15 plus summation t 0, 2, 5. Okay, so in this case they just give the don't care terms. Okay, so don't care term now, if it is needed you can take, otherwise don't care. Okay, otherwise you just omit the terms. That is what don't care. Okay, so in this case you can see this is the first maximum mapping, and after that you can see only one will be there. Okay, so in the normal case we just map like this, but it is a don't care terms. Okay, but don't care terms is available here as well as here. So instead of mapping this two alone, we just map like this and then make the simplification. So the final answer is y is equal to a bar b bar plus c into d. So this is what the don't care terms came up. So this is how we have to simplify the Boolean function using K-map. I hope you understand the concept of K-map. Thank you.